Sup YouTube, Youthful Rider here again. I'm doing a different video today. This is going to be a tutorial on how to create an involute tooth profile, a spur gear, on Creo Parametric. Right, so let's just jump right into it. I've got Creo open and I've got a Word document open. Now I'm going to probably put this in the description. If I don't, shout at me, but I probably will. Now, before you can actually make a spur gear, you need to know one thing, very important thing. You're going to need to do a bit of maths about it, and this kind of makes it a lot easier for you. So if you just literally follow this sort of stuff, you should be fine. So let's get started on the actual maths. I know that doesn't really sound very fun, but you kind of have to do it to get your gear to work. But there's 4 main diameters that you're going to be needing, and there's a little picture on it here. You need the root diameter, base circle diameter, outside diameter, pitch diameter as well. Now, when you're actually making your gear or choosing your gear, you'll know the pitch diameter. You might know the outside diameter, but let's say you know the pitch diameter. You can actually work that out by the module times the teeth number. Now, for what I'm going to be doing, I'm actually going to be, let me get something up quick. So what I'm actually going to be doing is making the pinion for one of my my gears. It's part of my coursework, but I thought, you know, it's actually quite a handy bit of engineering information, you know, or a tutorial that you can actually use in the future if you ever want to create something like this. Or if you enjoy doing this sort of thing, then you can just do it, I guess. So I'm going to be creating pinion 1, and I've just created gear 1, so you can kind of maybe have a look at how I've done that, but just follow this tutorial. It'll make it really easy for you, especially if I put this in. So I'm going to be doing it for pinion 1. So label this pinion 1. Let me just save it. So the first thing you need to do is you need to find the pitch diameter. You can do this, look online if you don't know enough information, but I know what module I'm using. I know the amount of teeth, so I've actually done this calculation. So the module I'm specifically using is 3, and the amount of teeth I'll have is 20, so 3 times 20, 60, right? So the PCD, pitch circle diameter, will be 60 millimeter, so I can put it on here. If you work in inches or anything like that, then well, good luck to you, you can convert that. Or you can keep everything in inches, but I'm not sure how that'll turn out. Just keep to the metric system, it makes things so much easier. So, the number of teeth I'll be using, on here you can see pinion 1 will have 20 teeth. That is pretty much the only information you're actually going to need now, so you can actually close this and you'll be fine. I'll leave it open just so you can admire my work. But, so, if we're following this Word document right now, we need to find the diametric pitch, which is N over D, makes it easy, 20 over 60. You can kind of see what's going to happen here. It's going to have the same diametric pitch, which is very much linked into the module, but it's more of an American sort of thing, I think. I'm not too sure about that, don't quote me on that, but that's all you need to do for that. So we know it's going to be 1/3. So base circle diameter, this is the first sort of thing. This is where your involute angle is going to start when you're creating it on Creo. So the equation for that is D cos PA, and PA is your pressure angle. Normally for spur gears, they have 3 different types. The first one, I think it's 14.6, I'm not too sure, they don't really use it anymore, but I think the most common is 20 degrees for a pressure angle and 25. Mine is going to be 20. If you don't know, if you're just doing this for fun, just consider it's 20, otherwise do some research. But yeah, so if you put this in the calculator, you can do it online or whatever. I'm going to do it here on my calculator. So the D is going to be 60. 60 cos 20. 60 cos 20, let's have a look at that. That is 56.38. 56.3816. Put it to 4 decimal places, you don't have to, but yeah. So, now you're going to need to find the addendum. I'm probably pronouncing that wrong, but this is basically telling you how much you're going to be adding on the outside diameter from the base circle diameter. So this is actually going to show you how wide your actual gear is going to be. So obviously addendum 1 over P, we know what P is, it's diametric pitch, it's 1/3. So 1 divided by 1/3 is equal to 3, which is the same as your mod. So it's already here from my last gear calculation. Your outside diameter, that is your next thing you need to find out. So from the outside diameter, we know that the outside diameter is going to be D, which is 60. 60 plus 2 times A. A, your addendum, 3. 2 times A is 6. You can kind of get an idea because your addendum is going to extend out one side and extend out the other side. So it's going to have 2 times the amount of whatever it's going to be. So 66. So we've got 2 of them already. If you wanted, you can go into Creo and you can make 2 circles with this in, but let's just do all the calculations first so we don't have to do anything. Right, your hole depth, HT. These are completely independent of what you want to do, but it's not too serious for what I'm doing, so I'm just going to say it's coarser than 20p. 20p, P is your diametric pitch, but it's just to do with the grain, I guess, but don't worry about that. Just use it as coarser than 20p. I won't do it for that. But so the equation for the hole depth, HT is equal to 2.157 over P. We know what P is, it's a third. So HT is 6.41. 471 for what I'm doing. It will be different for you most likely. Or if you're following just this. If you're following this exactly, then it won't. Your dedendum, I don't really know how it's pronounced, is HT minus A. So HT, we know what HT is, we've just worked it out, minus A, we know what A is 3, it's the addendum. We get rid of that, we find out what this is, which is B, which is 3.471. Okay, I did this on my last gear, so it's the same. Next thing, this is another important one, is your root diameter. So root diameter is a measure of where the actual, you'll see in a bit when I actually made the gear, but you do need this, it's very important. So your root diameter is D minus 2B. So my D is 60. Don't take that the wrong way. It's not 60 millimeters. No. Everyone who doesn't have a dirty mind is probably wondering what the hell I'm on about. 60 minus that, so put that in your calculator. 60 minus 2 times, what is it, 3.471. Let's have a look at that. That is 53.58. Exactly. Right. Okay, so that is done at the moment. That is literally all we need to do right now, except for the teeth angle, which we'll do now as well. So teeth angle is just 360 minus the number of teeth you have. The number of teeth I have is 20, so 360 divided by 20, which is 18. So teeth angle is 18. That's pretty much saying you're going to have an angle of 18 degrees for each tooth that's on the gear. Now let's just have a little look, see if everything's right. I'll probably skip. Oh yeah, no, I forgot to tell you. Right, this is your Involute equation for Creo. I got this off another YouTuber. I'll put his name in the description. I got all of this pretty much off him. Just I'm making it a little bit more clear and outlining some of the problems that occurred to a lot of people in his comments. It happened to me. That's why I looked. So for the Creo, the Involute equation, it's going to be R. When you're prompted to put this equation in, you'll see. Just copy and paste all this. It's going to be your base circle diameter divided by 2 to get the base circle diameter's radius. And we know what that is. So it's 56 point that. Just copy it and just paste it in here. Perfect. That's all you need to do now, and that is the math done. Right. So set your working directory to wherever you're going. Make a new part. Call it what you want. I'm calling mine Pinion 1. Pinion 1. Yep, that's all good. Now when you get into Creo, go to File, just as a pre sort of thing, go and prepare, Model Properties, change your units to millimeters, millimeter kilogram seconds, millimeter newton seconds, doesn't matter, make it to one of those, and interpret dimensions. Okay, that's done. So my Creo is probably going to be a little bit different to other people's, but you can kind of get how it works. So I'm going to click the front axis over here. I'm going to go Sketch, get into Sketch View. It might already do that for you. We're going to make 4 circles, and these are the circles that we have calculated. So I suggest you literally just make 4 circles right now and just change the dimensions later. So, first circle, we know it's going to be 60 because that is the diametrical pitch, or not diametrical pitch, that is the pitch circle diameter. The next thing we need to change is the outside diameter, which we know is 66, which we've worked all of this out here if you have a look. 60, 66, next one is 56, one, blah blah blah. Just copy and paste it, save yourself a bit of time. Cool, next one is the root diameter, copy that. Right, now, normally, well I shouldn't say normally, sometimes the root diameter and the base circle diameter will fluctuate, one will be bigger than the other, but what you have to remember is that the involute angle will start on the base circle diameter, which is 56, so it's going to start on the second largest or the second smallest circle here. Press OK to that and you'll see you have 4 circles and they're all the right dimensions now. This is where the involute angle is going to come into place. So we're going to go onto datum, curve from equation, click on that. Our reference, click on that, is this here, center point of this circle. Then you click on equation and close that. Copy and paste the involute equation, paste it in there, get rid of this mess here. You can copy that and press OK. As soon as you press OK, you'll see something here. There is an equation here. There is a curve, really weird curve I might add. Should see. Oh, that hasn't done it. Anyway, so with this curve, from 0 to 1, change that to, I don't know, 0.3. Let's see what happens. No, that's too small. Change it to 4. Yeah. So you basically want the outside edge of this curve to kind of come out of the last circle, the largest circle, and that will make life a little bit easier for you. Press OK. Next thing you're going to do is copy this little curve. Click on it. Well, click on it like that so it doesn't highlight all in green. I'll just click up here and then press copy and then paste. You're going to want to paste special and then paste special. After that, apply, move / rotate transformations to copies. Okay. Now you're going to want to, my bad. So you're going to actually want to put this on a rotational axis. So rotate features about selected reference, and then your reference will be, if you move this down here, your z-axis. Click on that. Now you can rotate it. Now that's where your teeth angle comes in handy. I want you to rotate it 18 degrees or whatever your teeth angle was. Mine's up there. So that's the first part. You're going to do exactly the same thing. So go on your curve one, copy it, paste special, blah blah blah. You've done this all before, you should know this. Now rotate it about the z-axis again. Now what we're actually trying to do, make sure it's on the z-axis, it's rotated halfway there. So if you got a big number here, just put the big number in and divide it by 2. But I know what 18 divided by 2 is, so just put 9. And then you'll have the same curve halfway in there. So that's done for that part. So now the next thing you need to do is make points along these. So the first point I'm going to make the center point of this circle. Okay. The next points I'm going to make are the lines that intersect this and the pitch circle diameter. So the second largest circle. So make another point along these curves. All of these curves should have points that intersect these lines here. You can see what I'm doing. If you don't understand what I'm saying, just look at what I'm doing and you can pick it up. Right, perfect. So now what you're going to do, you're going to select these points. You can either select them here, it's a bit difficult too, but over here on your little navigation tree, select point 1, select point 0. 0 is your center line, 1 is the first point that you made, I think down here. You're going to go datum, curve, then curve through points. That will make you a little line, press yes. Okay, then go to point 2 and 0, because you're making lines that want to, you're going to make lines that go down into the radius, or into the center of the circle, from the pitch circle diameter and these points here. So click point 2 and 0 now, datum, curve, curve through points. Okay, last one, point 3, point 0, datum, curve through points. You can rewind this video and everything if you haven't got this far, but this is probably about halfway through, and you're pretty much, well, you're pretty much there actually. So the next thing is you want to make an axis. So an axis along the z-axis. So there's your axis symbol. Oh, that didn't work. That's not you. Yeah, datum axis. You're going to click your z-axis here. That's going to make an axis about the z-axis. This is going to be your rotational axis for this gear. Put it on front view, see what's going on. What you want to do is mirror this curve in the middle, and the way to do that is use this line that you've created and that axis. So click on this line in the middle and click on plane, then click on the rotational axis. Didn't work, did it? There we are. So hold control when you click it, hold control when you click the line, hold control and then click Z. So click them both while you're holding control, and that will make an axis along that line there that you created. Press OK. Put it in front view so you can see it's definitely on there. Yep, that plane is perfect. So click on this curve now, press mirror, that's the mirror symbol, and click the plane. It didn't work for some reason, it's been a little bumhole. Okay, no it did. Just press, okay, it should go. There we are. Sorry, normally it automatically pops up. Right, so that is the hefty stuff done now. Now is the fun stuff, actually making the circle come up to life. So what I like to do is click on your front axis here, or your front datum, your front plane, and click sketch. Alright, now make sure you're in sketch view. Now at this point you can actually see that there's a tooth forming right here. If you follow my mouse, that is going to be the tooth. These angles have made a tooth. So you're going to click onto, let me make this bigger actually, it might make it easier for you. You're going to click onto project, okay? Move this here, click onto project, and follow the lines that I'm clicking. Click these two curves here. Sometimes those will not select. That is one of the biggest problems. If they don't select like this, click on the offset, click on them, and this get rid of all the random stuff, all the random lines that you don't want. But you'll see what I mean in a sec. So if it does click, good for you. If it doesn't, bear with me. So then after you've clicked those two curves, click these lines here. So you want the next lines to be the outside diameter and the pitch circle diameter here. That's going to be your tooth. The tooth comes from the pitch circle diameter to the outer diameter. Right, once you've clicked those lines, you're going to go delete segment. Right, and you're just going to get rid of all this garbage out here, because you don't need that, until you're left with just these lines here. See what I mean? This tooth sort of angle. It's not going to work at first because there's going to be lines up here, which you want to get rid of those as well. Just swipe across them like that, or click on them, doesn't matter. And then you should, let's see, I had a few that were just lying there. There's another one. You should be able to click select up here. It should be, nope, there's one more there. Get rid of that. And it should just be a solid mass like that. Now, for the people who couldn't click on these curves, click on offset, you'll click it and you'll have loads of selections here that you'll need to click. Press on delete, click on delete segment, get rid of all this random stuff. you'll see it's here. It's a bit complicated at first, but you get used to it. So get rid of all that till you have a solid mass, solid loop here. Make sure there's no open loops where lines are just sticking out. You want to get rid of all of it. And then once you've done that, click OK, then extrude. You're going to want to make it come to life. Now, this is where I suggest, if you're not too bothered, you're just having fun, just make it 30 or whatever you want to do. You know what I mean? It doesn't really matter, but if you're doing what I'm doing, you're going to make it a little bit more professional. You want to actually know what sort of size you're looking at for the width of this gear. Go on to a site, HPC Gears. It might not be around when you go on this, I'm sure it will though. Go on to Spur Gears over here, or actually I'll go here. On product selection, click Spur Gears, type of gear. Whatever you're doing it for, my module was 3. Take you to a catalogue where you can actually have a look at this stuff, and you can see here that this width is actually 30 mil, so that tells you some of the stuff. You can actually see here, if I go onto a tooth, well, there was 20 teeth, so it's going to have 20 teeth. The PCD is going to be 60, the outside diameter is going to be 66. That's exactly what we've gotten on our calculations, so we know it's right. So I suppose you can look at this, but it doesn't give you the root diameter or anything like that. So make sure you know what that is. You don't have to, but if you want to make it a bit more professional, then do that. So we know it's going to be 30. I've set my extrude length to be 30. Next thing you're going to do is create the root. So the root diameter, this is what the base root diameter, I think it's called. Yeah, there we are, the root diameter. We know what the root diameter is. It's the smallest circle here, so we can easily find it. This is from the pitch circle diameter, your second largest circle, to the smallest circle, but your root diameter might be up here, so just check it, just make sure. So you're going to need to do it from these lines. Mine's easy, mine's going to be from that line to that line. Yours might be from that line to that line. So that's something you might want to look into, but I'm sure you can work it out. But pretty much if you connect the lines from the pitch circle diameter, your second largest circle, to the lines that aren't connected to the involute angles, then you should be alright. Doesn't matter if it overlaps or anything. So this is what you're going to do. Click on the front again, click sketch view, just so you know you're in the right place. So what this actually is going to be, click project, is it's going to be where the teeth actually sink into. So you need this space. Follow me again, click on the outside diameters here. Oh, down here. See, nearly did it. Well, the one that's not connected to the involute tooth angle or the curve. Then these lines here. And the same for people who might not be able to click on this, click on the offset and you'll be able to do it. It's a little bit more fiddly, but you know. So just follow what I'm doing. I'm getting rid of these lines here, making it a solid block right in the center here. So that should be, this lines up here as well, get rid of those. There might be some on the other side as well. There's not. So you've got a solid block here. If you click on the block, you'll be able to, well, there it is. That's all you're looking for. You're looking for a closed loop. That's what defines an extrude, I think. So if you click OK, go on to sketch 3, you want to extrude this thing that you've done now. Going to go 30 as well, but difference with this is it's going to remove material, and I'll get onto that in a bit. So do that. Just click on it normally for now. Now you have these two little things that you don't know what to do with. Now, if you click on the front again, you're going to make one more sketch. Get to sketch view. Now click onto the pitch circle diameter, which is this. You're going to select it. You're going to make yourself one. You can either go from the center and make it 60, or you can project. Click on that, and then voila, you have a pitch circle diameter. Okay, you can extrude that as well, make that 30. Okay, now get to front. Now you want to remove this little material thing that you've done. The way to do that is, it's probably not going to work right now because I've done that the wrong way around, but you might be able to get away with it. Click remove material, press OK. Yeah, it hasn't worked, so just literally drag your extrude down one like that and it should do it. There we are. So that's what you're looking for. That is going to be the profile of the first tooth and the first root, I guess. Now you're going to want to actually mirror these, so click on your extrudes. Extrude 1 is the tooth. Click on that. Click on pattern. Sorry, I said mirror. You're going to want to pattern it. You're going to come over here, select axis. Remember that Z axis that you made, that axis 1? Click on that. That's the rotational axis. This is going to be the number of teeth you're going to have. I'm going to have 20 teeth, so it's going to be 20, and click on this to make it all the way around. Put 360 in there, and then OK. And there we are, you have teeth. Next thing you're going to do is go onto your extrude 2 or your root, whatever it is. You might have done it a bit better than me and done it at the end, which is what you should have done, but it's fine, it'll work either way. Go onto your extrude 3, you're going to pattern it along the axis 1 again, this axis that you've made over here somewhere. So click on axis, find it here, there it is. Okay, that's also going to be 20 teeth, or how many teeth you have. Do that, and there we are. Now you've made yourself a gear, except you need to actually include a bore on it. If I look on my little Spur gear sheet, we know what the bore is here, or the minimum bore. So 25 mil, that's going to be the bore. So if you want to finish this off completely, click on front again, click on sketch view. Right in the center of the circle you're going to want a bore of, what was it, 25? I don't remember. Yeah, let's say 25. That seems a bit big, but sorry, my windows are all over the place. And press OK. Extrude that to 30 mil. Remove material, and there we are, you have a gear. See, not too difficult. I'll practice that a few times, you'll be a pro. And in my next tutorials I'll be showing you how to make 2 gears that will link together and rotate. That's actually on the same YouTube channel I found this off of, but it's a little bit clearer the way I've done it. No offense to him, he did a really good tutorial, but this is going to be a bit clearer. So there we are, that's the end result. Have fun with this. I hope you learned something. It's a really good skill to know in the future, how to actually create one of these. You can do it with helical gears and everything like that, worm gears, but this is the most simple gear to do it with. So yeah, hope you enjoyed the tutorial, and thank you very much for watching.